Hello all, I am Saraswati working as Associate Professor, Department of ECE, K.S. Rangaswamy College of Technology. The course name is Digital Logic and Microprocessor. Today we are going to discuss about multiplexer and demultiplexer. So these are all topics we are going to discuss. Introduction, multiplexer, block diagram of multiplexer, logic symbol, logic diagram of multiplexer, truth table, demultiplexer, block diagram of demultiplexer, logic symbol of demultiplexer, logic diagram of demultiplexer, truth table, and finally application. Let's see one by one. The topic is multiplexer. So now what is multiplexer? A multiplexer is a logic circuit that accepts several data inputs and allows only one of them at a time in get through to the output. The another name of multiplexer is called a data selector. The simply defined multiplexer means many into one. Multiplexing is the process of transmitting a large number of information over a single line. The definition of multiplexer, a digital multiplexer is a combinational circuit that selects one digital information from several sources and transmit the selected information on a single output line. The multiplexer has several data input line and a single output line. So that means there are two power n input lines and n selection lines. So here the bit combination determines which input is selected. Multiplexer directs one of the inputs to its output line by using the selection line to its select lines. The multiplexer consists of data inputs, selection inputs, single output. The selection input means it determines the input that should be connected to the output. Multiplexer acts like a digitally multi-position switch or electronic switch that selects one from different form. So let's see the block diagram of multiplexer. This is a 2x1 multiplexer block diagram. Here the selection input is a 2 and the data input is 4 and only one output. So this is a logic symbol of 4 to 1 multiplexer. So the input selection line is 2 and input is a 4 and only one output. So this is a logic diagram of 4 to 1 multiplexer. When the selection input combination S1 S0 is 0 0 0 0, the D0 input is passes to the output and the S1 S0 is 0 1 is applied to the selection input and the D1 is passes to the output. So therefore Y is a D1. And the S1 S0, when S1 S0 is 1 0 is applied to the selection line and the C2 is passes to the output line. When S1 S0 is 1 1 is applied to the selection line and the D3 is applied. The D3 is selected to the output. So the output line is a D3. So the next, if S1 S0 0 0 0 0 is applied to the selection line, therefore the output is a D0. When the S1 S0 is 0 1 is applied to the selection line, the data input D1 appears on the data output line. If S1 S0 is 1 0 is applied to the selection line, the output and the input D2 appears on the output line. Similarly, S1 S0 is 0 1 is applied to the selection line. D3 is passes to the output line Y. So in general, 2 power n to 1 multiplexer is connected from n to 2 power n decoder by adding to its 2 power n input lines, one each AND gate. So the size of the multiplexer is specified by the 2 power n of input line and the single output line. The output of the AND gates is applied to the single OR gate to provide the single output. So the enabled input can be used to cascade 2 or more multiplexer IC to construct the multiplexer with larger number of inputs. So the multiplexer IC have an enabled input to control the operation of the unit. So this is a truth table of 4 to 1 multiplexer. The selection line is 2, S1, S0, the output is a Y, 2 power n input, 2 power n input lines and 1 output lines. So this is a truth table, 0, 0, the output is a D0, 0, 1, the output is D1 and 1, 0, the D1 is, the D2 appears on the output line, 1, 1, the D3 data lines appears on the output line Y. So this is a 8x1 multiplexer logic diagram. Okay. So next